In this video, we will be picking up where we left off in section 7.3 with the comparison of the disk and shell method. Remember, the disk method is where we're trying to find the volume of a solid revolution, and we use a bunch of disks or washers. And the shell method is where we're again trying to find the volume of that solid revolution, but instead we're using cylindrical shells or like hollow tubes. So the disk and shell method can be distinguished as follows. For the disk method, the representative rectangle, right, the rectangle that I always draw is, in this case, perpendicular to the axis of revolution. For the shell method, the representative rectangle is parallel to the axis of revolution. One easy way to remember is shell has two L's in it and parallel has two L's in it. All right, so for the shell method, our representative rectangles are parallel to the axis of revolution. So in other words, if I have a horizontal axis of revolution, my rectangles will be horizontal. For the disk method, if I had a horizontal axis of revolution, then I would have a vertical rectangle, right? So up here, like if I had something like this, that would be what I would have. If I had a horizontal axis of revolution, I would have a vertical. And here, if I had a horizontal axis of revolution, I would have a horizontal. Right? So that's what I mean when I say parallel or perpendicular. Right? So in some cases, one method is more convenient than the other. Right? And we have these cases labeled here. So example 3, this is a problem where the shell method is preferable. So let's find the volume of the solid formed by revolving the region bounded by the graphs of y equals x squared plus 1, y equals to 0, x equals to 0, and x equals to 1 about the y-axis. So oftentimes when I give you these problems, like maybe on an exam, I won't tell you which method to use, right? You'll have to determine it. So the first step here is to draw it and see what we've got. So if we're going to draw this here, this is my graph. I want to draw x squared plus 1, so that's the parabola x squared shifted up 1, right? And we actually only need the right half of it because we're bounding it by the x and y axis, right? Y equals 0 and x equals to 0. So this is, draw a little bit better. This is y equals x squared plus 1, and then we need the line x equals to 1. So that's like this line right here. This is x equals to 1. So my area that I'm revolving is right here. And what am I revolving it around? I'm revolving it around the y-axis, right? So I have a vertical axis of revolution. Okay, so this example says the shell method is preferable. Let's explain why. So let's say what's the issue with the disk method. If I were going to try the disk method, right, since this is a vertical axis of revolution, for the disk method, remember my representative rectangles are perpendicular. So that would mean I would need a horizontal representative rectangle. Right? So my rectangles would look like this or like this. Right? Remember when we had an example kind of similar to this, because something strange happens right here. Right? If I was drawing these horizontal rectangles, right? If I had a rectangle down here, I would very easily be able to say, okay, my outer radius is x equals 1, my inner radius is 0, boom. But then if I go above, this is x equals to 1, or I'm sorry, y equals to 1, then my inner radius, right? If I drew this rectangle here, my inner radius would be the purple one, and my outer radius would be x equals to 1. So in other words, I'd have to have two integrals. Having two integrals is inconvenient, right? So that is why, in this case, the shell method is preferable. Oopsie. All right. Okay, so now let's go ahead with the shell method. So with the shell method, remember I have a vertical axis of revolution, so I know I have vertical rectangles, which means I need to integrate with respect to x. Because if I have a vertical rectangle, if I were to draw a vertical rectangle right here, this right here is delta x. All right, so that's why I'm allowed to integrate with respect to x. And again, we're a little bit more comfortable with that too. Oops. And I probably should have mentioned this too. In the case where if I was looking at the disk method, if I were going to draw those horizontal rectangles, this would be delta y. So again, I'd have to integrate with respect to y. So that's one more reason why I wouldn't want to do that. Because integrating with respect to y is a little bit more tricky. Ugh. Sorry, guys. Very good at my eraser. Okay, so again, shell method. Where are we at? Vertical rectangles, we want to integrate with respect to y. So let's draw my rectangle here. Right, we know this is delta x, and what do we need to know? We need to know where we start and finish. Start and finish is going to be pretty easy, right? If we're integrating with respect to x, we know we start here and we end here, so that's x equals to 1 and x equals to 0. Now I just need to find my p of x and my h of x, right? So the height of my rectangle here, this is my h of x. The height of my rectangles, so I guess I don't need to really say height, you know what h means. So let's go ahead and just say what h of x is. The height of those rectangles is given by the purple function, right? X squared plus 1. Okay, and then now what is the other thing we need? We need p of x. P of x is the distance from the center of the rectangle to the axis of origin, which is the y-axis. And remember I said oftentimes when our axis of revolution is the x or y axis, then our p of x or p of y is going to be their x or y. So in this case, our p of x here, our distance from the x-axis to our rectangle is going to be x. So then my volume is going to be 2 pi, the integral from a to b, p of x times h of x dx, right? That's in general the shell method. So now we plug in our values, 2 pi, the integral from 0 to 1 of p of x, which is x, times x squared plus 1 dx. So I get 2 pi times the integral from 0 to 1 of x cubed plus x dx. And if you integrate that, you end up getting 3 pi over 2. So again, in this case, the shell method was preferable. The disk method was possible. It would just take a little bit more work, right? But you'd get the same answer. Okay, so now let's look at an example where the disk method is preferable. So again, first let's draw the picture here. So this is pontoons made by rotating the graph of 1 minus x squared over 16 for x from -4 to 4. 1 minus x squared over 16. So 1 minus x squared divided by 16. And notice here this cross, so it's a big parabola, right? And it crosses the x-axis at -4 and 4, right? So let's go ahead and draw this. Draw a little bit bigger. All right? And we know that these values, we could solve for them, but we could also just see in the picture that this is +4 and this is -4, right? If we set this equal to 0, we would get those values of +4 and -4. Okay, and so what's the area we're interested in here? This is the area we're interested in. And where are we going to revolve that? We are going to revolve that about the x-axis. All right, so our axis of revolution, or I guess I should, the way I did it before, I say we have a horizontal axis of revolution. Okay, so in this example here, it says that the disk method is preferable. So let's explain why the disk method is preferable. So let's see what would happen if we tried to do the shell method. So if we try to do the shell method, we have a horizontal axis of revolution. That means we need horizontal rectangles. If we have horizontal rectangles like this, that means that the the width of those rectangles is delta y, right? So that means we need to integrate with respect to y. To solve, so in order to integrate with respect to y, we need to solve y equals 1 minus x squared over 16. So let's not say to solve, but we would need to solve that for x. So solving for x is difficult. All right, I'd get a big square root, I'd get a plus or minus, and that wouldn't be very fun. All right, so that's issue number 1. When I would try to solve for x, because I need to integrate with respect to y, so it's x equals something, 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 I would have a little bit of issues. Also, if I were to then do the shell method, I'd end up with a integral that requires u substitution, right? Which again is just making life more and more complicated. It's possible to do it by the shell method, but again, it's not preferable. So now let's look at the disk method. Okay, so with the disk method, remember, if this is a horizontal axis of revolution, then I know I need vertical rectangles, right? What do vertical rectangles mean? If I have a vertical rectangle, that means I'm going to have a delta x here at the bottom, right, for the width of rectangle. So I know I need to integrate with respect to x. So all my equations can be y equals x something, 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 right? And that's convenient here because our function is already in terms of y equals x something, 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 right? Okay, so I need vertical rectangles. So my rectangle looks like this, right? I know this is delta x. Remember, for the disk method, we need to find a inner radius or an outer radius if it was a washer. In this case, it's actually a disk, because if I'm revolving it around the x-axis, it's not hollow, it's solid, right? So in this case, we actually just need to find that radius, right? So we can very easily see that the radius of my disk, right, this right here, is just going to be given by the function, right? What's the function? What's the purple graph? 1 minus x squared over 16, right? And that's all we need, right? The disk method says the volume is equal to pi times the integral from a to b of whatever my radius function is squared dx. So in this case, it's pi times the integral. We start at -4. We end at 4 of my function, which is 1 minus x squared over 16 quantity squared dx. Remember, the thing we have to keep track of here is that this is 1 minus x squared over 16 times 1 minus x squared over 16. Remember, when we square a binomial, we need to FOIL, right? But there's that tricky, or not tricky, but there's that nice trick where I say, okay, square the first one. So 1 squared, 2 times the first times the second. So 2 times negative x squared over 16, which would be giving me negative x squared over 8, because 2 divided by 16 is 8. And then plus x to the 4th over 256. Right, that would be 16 squared. Okay, and so now if I integrate that, I get my final answer to be 64 over top of 15 times pi. Awesome. So again, in this problem, we could have done the shell method. Life would have been a little bit trickier, but it was possible. The last problem here is the shell method being necessary, right? And so I'm going to make a little note of why the shell method is necessary. So if it is impossible to solve for x and the axis of revolution is vertical, then we must use the shell method. Right? And I'll explain why in this example here. But that, if it's impossible to solve for x and the axis of revolution is vertical, then we must use the shell method. Right? So let's look at this example here. We're going to find the solid of formed by revolving the region bounded by the graphs of y equals x cubed plus x plus 1, y equals 1, x equals 1, about the line x equals 2. Right? So x cubed plus x plus 1. So x cubed plus x plus 1, and then we had the x equals to 1, y equals to 1, and x equals to 2. So x equals 1, y equals 1, and what was our last one? X equals to 2. X equals 2 is what we're revolving around, though. X, whoops. And x equals to 2. Okay, so the region we're looking at is the region that's bounded by the green, the purple, and the black, and we're going to revolve it around the line, the red line. Right? So the green line is really what we needed help graphing, and so that is it looks kind of like the cubic function, but it's centered at 1. Right? So it looks like, oops, get a little more up. This. So this is y equals x cubed plus x plus 1. And then I had the line x equals to 1. So go at the x value 1. You got this right here. This is x equals to 1. And then we had y equals to 1. So that's a horizontal line at y equals 1. Y equals to 1 was where we crossed the x-axis here. So, sorry, I'm going to try this again. I'm going to draw a little bigger. I apologize. So this is going to be y equals x cubed plus x plus 1, right? And then we have y equals to 1. So again, that's where we cross the x-axis here. And then we have the line x equals to 1. So that's like right here. Again, I really didn't draw it that much better, but you get the idea, and we're going to revolve it about the line. I'm going to move this around, move this around. X equals to 2. So this is going to be where we're revolving it. All right? And so let's color in our area. Our area is right in here. This is our area that we're going to revolve around that red line. Okay, so let's talk about why the disk method is impossible here in this case. So notice my function, which is y equals x cubed plus x plus 1. I can't solve that to get x equals something. If I tried, I would subtract 1, and then there's no way I could get x by itself, right? So notice that that cannot be solved for x. So in other words, what does that mean? That means that we cannot integrate with respect to y, because if I could solve for x and x equals y something something something, and I could integrate with respect to y, but I can't solve for that, so I can't integrate with respect to y. So what does that mean? I must integrate with respect to x, right? So I must integrate with respect to x. So what does that mean? Well, to integrate with respect to x, what does my rectangle have to look like? My rectangle has to be vertical, right? So if I want to integrate with respect to x, I'll draw it over here. Then I need delta x to integrate with respect to x. So in other words, my rectangle must be vertical so I can get delta x for my width. My rectangle must be vertical, right? Now, if I know I need to have a vertical rectangle, right? A vertical rectangle like this. Vertical rectangle going around a vertical axis of origin, that means parallel, right? So I have to do the shell method, right? So since my axis of revolution is vertical, and I know I need vertical rectangles, we must use the shell method. So that is why we have to use the shell method in this case, right? And my little star up here at the top basically is saying that whenever we can't solve for x and we have a vertical axis of revolution, we know we have to use the shell method, right? So now let's go ahead and use the shell method. So what do we need to know for the shell method? We need to know where we start and where we finish, and we need to know our P and our H, right? So first, where we start and where we finish, right? Here's where we start. I know my graph's not perfect, but we start at x, or I'm sorry, these are going to be, we need x values, right? So where we start and finish, because these are vertical rectangles with delta x here, we need the x values where we start and finish. So this is one x value where we start. So this is x equals to 1, and the x value where we finish, or I'm sorry, this is x equals to 0, and this is x equals to 1. Cool. Okay, so now we need to find p of x and h of x, right? So p of x, remember, is the distance from the x-axis to, our axis of revolution to the center of our rectangle. Right, so in this case, what is p of x? P of x goes from the middle of our rectangle to our axis of revolution, right? So that's why P of x is a little bit tricky now. How are we going to find P of x? Well, we know that this distance right here, from here to the center of our rectangle, right, from here to here, that is x, right, because that's the x value we plug in. But we don't want that. We want this distance that's from here to here, right? So how are we going to find that red distance? Well, we take x equals to 2, which is the whole distance here. This is x equals to 2. We subtract away. So I take this whole distance here, which is x equals to 2. So I'm going to go ahead and write that out. So P of x equals to 2. Then what do we subtract? We need to subtract this right here. And that will leave us with this right here, which is what we want. Right? So what is this orange that I'm coloring? That orange that I'm coloring is x. Right? So I need 2 minus x. Right? I guess I can leave that pink x in there because that might be kind of nice. So the distance from there to the center is x. So if I want to know P of x, I take the total distance from the y-axis to x equals to 2, which is 2, and then I subtract out the pink, which is x, and that will give me P of x. So hopefully that makes sense to everybody. Now h of x, remember h of x is the height of my rectangle. So again, this one's going to be a little bit awkward too, right? I want the height of my rectangle. This is my h of x. Normally, what I would do, the height of my rectangle is just my function value, right? It would just be like the purple. But the purple, remember, the purple tells us from the purple graph to the x-axis. I don't want that. I want from the purple graph to the blue graph, right? I just want this piece right here. So in order to find that piece right there, I need to take the purple graph, which is x cubed plus x plus 1, and I need to subtract what the blue graph is. What is the blue graph? That is x equals to 1. Right? Because remember, this is x equals 1. Right? And this is so now I simplify this and I get the h of x is equal to x cubed plus x. And now I can solve. So in general, for the shell method, 2 pi and the integral from a to b of p of x, h of x, dx. So now 2 pi, the integral, where do we start? 0. Where do we end? 1. Because we're integrating with respect to x. Those are starting and ending x values. P of x, we know, is 2 minus x. H of x is x cubed plus x dx. So I get 2 pi, the integral from 0 to 1 of 2x cubed plus 2x minus x to the 4th minus minus x squared dx. And if I were to integrate that and get my solution would be 29 pi over 15. So again, this was an example where the shell method was required, and this was also an example where that P of x was not just x, or that P of y was not just y, right? Because my axis of revolution was something other than the x or y axis. So that's why we had to work a little bit harder for P of x.